Now the video you've probably all been waiting for. Let's go through some combination circuits and see how we approach solving for different variables. So taking a look at this circuit, I can see that I have parallel and series mixed into the same. These two are in parallel with each other, and then those two are in series with R1. And so how do I go about condensing this and finding my equivalent resistance? Well, first it may help to redraw. So if I have my battery voltage here, I'll put R1 right here and then redraw it like this. R2 and R3 in parallel, and it goes back to the battery. So here's R2, here's R3. So what I need to do is take these in parallel and condense them to one resistor. So I'm working from the inside out. So I know I can combine these two in parallel. And so how do I do that? Using the equation that we know. And I get one resistor that is resistor 2 and 3 combined. Now I see that I have two resistors in series. So to combine those, all I have to do is just add them. And when I do add them, I'm left with one resistor that is R1 plus resistor 2 and resistor 3 combined in parallel. And this is my equivalent resistance. And so I know I can use that, that's delta, to find my total current. And then once I have my total current, which is this, I know my total current is running through R1, and once it gets to this junction here, it splits. And I have two different currents, I2, which goes through resistor 2, and I3, which goes through resistor 3. So how do I solve for these currents? Well, the trick is to draw your loops again. So I've got the loop that I2 takes, and then I've got the loop that I3 takes. And let's go ahead and add our voltages. So in loop 1, I start with the voltage of the battery. Then I have to add the voltage drop across R1, because before it even gets to the junction, it goes through resistor 1. And then once it passes through the junction, I2 goes through R2. And when it gets past R2, it's got nothing else, so that has to equal 0. Same thing with R3. I start with the battery voltage, I go through R1, and then I go through R3. And I know that has to equal 0. So now we're presented with a problem. I have three unknown potential drops, and now, since I have this pesky little resistor 1 here, the voltage drop across resistor 2 and resistor 3 is not equal to the voltage drop of the battery, or the voltage supplied by the battery. So what I have to do is I have to solve for delta V1. So delta V1, the current running through that is the total current. So all I have to do is take the total current times R1, and I get delta V1. And I just solved for my total current earlier. This will be more clear when we do an actual example. Once I have delta V1, then I know that my battery voltage minus I times R1 plus my delta V2 is equal to 0. And so using this, I know these two things, I can solve for delta V2. And I know that since R2 and R3 are in parallel, I've got my potential drop across 3 too. And then, when I have those, I have potential drop across 2, and I know the resistance, so I can solve for I2 in that one. And then I have potential drop across 3, resistor 3, so I can solve for the current through 3. So let's do an example with numbers, because I think it'll be easier to see when we do that. So I have a 12-volt battery connected to a 2 ohm resistor in series with the 5 and the 10 ohms in parallel. So just like last time, let me redraw this. I've got 12 volts, and I've got a 2 ohm resistor. That was terrible. In series with a 5 and a 10 in parallel. And so what did we do last time? We took these, combined them in parallel. So I've got 1 over 5 plus 1 over 10. So what is that? 3/10 equals 1 over that equivalent resistance. So the resistor that should replace those two is 10/3, or 3.3 ohms. So what I do is I cross those two out and replace them with one 3.3 ohm resistor. Now I see that I have two resistors in series, and I know that is easy, because to combine those, I just add the two. So here, my equivalent resistance is just 5.3 ohms, and that's my equivalent resistance of the entire circuit. So now using that equivalent resistance, I can say Ohm's law, voltage of the battery equals my total current times my equivalent resistance, so 12 equals I times 5.3. And so my total current then is 2.3 amps. So I've got total current of 2.3 amps. So that's the current going here and coming back out here. So now I want to know what's the current running through resistor 5 and what's the current running through resistor 10. Now, if I take the path of current 1, I start with 12 volts. Then I know my potential drops, and I know that Ohm's law is V equals IR. So when I hit this 2 ohm resistor, I know I have 2.3 amps running through it. So that's the I, and then the R is 2. And then I know that the potential drop across the 5 ohm resistor added to that equals 0. Same thing happens across the 10. I start with 12. I still go through that 2 ohm resistor with the total current, and my potential drop across that 10 ohm resistor added to what I already have is also 0. And so if I look at my first equation, this is 2 minus 2.3 times 2, which is 4.6. And so when I subtract those, I get 7.4 volts. That means the potential difference across the 5 is 7.4 volts, but that's also equal to the potential drop across the 10 ohm resistor as well. So now that I've found the potential drop across these two resistors in parallel, I now can come back and use the magical equation, Ohm's law. So the potential drop, which I just found, is equal to the current times the resistance, which is just 5 ohms. My potential drop is 7.4. So 7.4 divided by 5 would be 1.48 amps. So I1, 1.48 amps. Now I could go through Ohm's law again and say delta V10 is equal to I2 times 10. So 7.4 is equal to I2 times 10, so therefore I2 would be 0.74 amps. So I2 is equal to 0.74 amps. Now what happens when I add these two together? 1.48 plus 0.74. Well, what happens when I add these is I get that I is equal to 2.22 amps, which we know is not equal to 2.3 amps. But this is okay because when we found 2.3, or when I found 2.3, I really rounded. This is more like 2.26. And so the rounding threw off the other numbers, which threw off this by that much. And so that's okay. And so now we found everything we can find. Potential drops, currents, resistances were given. And so I hope this helps in thinking through combination circuits. And they do get more complicated. So if you have any more questions, ask me. I can make more videos if I need.